then you are supposed to find the roots of a complex number. So we are going to work out, we are going to have a discussion step by step on how you can be able to find roots of a complex number. For instance, you are told, solve the equation, just right here, solve the equation, and this is basically further pure math to roots of complex numbers. And in this case, first we need to say that this is z power 5 is equals to 32i. Now, the first thing that we're going to do in this particular question is that we need to find what is the argument when you have z is this. So if you sketch that on an Argand diagram, of course, this is going to be our real z, this is going to be our imaginary point, imaginary z, of course. And then since this is on the imaginary part axis, this is going to be somewhat 32 here, right? 32i, it's positive number. Then it means the angle measured in that particular direction is going to be the angle here, which is 90 degrees. And remember, 90 degrees is equals to pi over 2 radians in that case. So which means we can be able to write this question in modulus argument form. And under modulus argument form, of course, we are supposed to be giving give your answers in form of r a I theta. So we are going to give our answers in Euler form. So in modulus argument form, this part can be written as z power 5, right, is equals to 32 cos pi over 2 plus I sine pi over 2 in modulus argument form. This is how this particular question is going to be given. But something that we need to appreciate at the same time is that the argument is not a unique value. You can be able to write this as z power 5 is equals to 32 cos pi over 2 plus 2 pi k plus I sine pi over 2 plus 2 pi k. So we can be able to find a set of values of these complex numbers within this, and k is a member of z, is an integer in that case. So k can be equal to 0 plus or minus 1 plus or minus 2 plus or minus 3, and so let this z be equals to r cos theta plus I sine theta. So that is the approach we're going to use, so that we can be able to say z raised to power 5 is going to be what. Okay, so in this case, let me just right here. So which means our equation that we are having here can be written as r raised cos theta plus I sine theta power 5, because we are saying that let z be this, but our z was raised to power 5. So this is going to be what? Of course, this is also having a bracket. R into bracket this raised to power 5 is going to be equals to 32 cos pi over 2 plus 2 pi k plus I sine 2 pi k, not that, pi over 2 plus 2 pi k. So that we are going to have this, and then we shall enclose in bracket like that. So once we have identified this, we can be able to apply the Weaver theorem De Moivre's theorem, and that is going to be r power 5. The Moivre's theorem says if you raise to the power, this modulus r is going to be raised to power 5, but this one is going to be cos 5 theta plus I sine 5 theta is equals to 32 into bracket cos pi over 2 plus 2 pi k plus I sine pi over 2 plus 2 pi k, like that. So we shall see r raised to power 5 is equals to 32. That is the first thing we're going to do. So it's going to be r power 5 is equals to 32, and this implies that find the fifth root. Our answer becomes r is equals to 2. R is going to be 2. So the next thing we're going to do is also, you can equate, you can see 5 theta is equals to pi over 2 plus 2 pi k. So we are going to say 5 theta is equals to pi over 2 plus 2 pi k. Now in that case, we are going to, if I multiply all through by 2, I'm going to get 10 theta is equals to pi plus 4 pi k, and then I'll divide by 10, divide by 10. So my theta is going to be equivalent to what? My theta is going to be equivalent to pi plus 4 pi k over 10 in that case. So now we're going to have a set of values of theta which is going to define the root. And in this case, in this question, we were given, in this case, when you are finding your solution, theta should be less than 0, greater than 0, greater than 0, but less than 2 pi. So this is the range of values of theta that was provided. So in that case, what we're going to do, we are going to say when k is equals to 0, we shall start, because the solution is going to be a set of values. So we shall start with k is equal to 0, because you remember here we said k is a member of integers 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. So the first one is when k is equals to 0, then we are going to say our theta is going to be 0, this is pi plus 4 pi times 0, that will be pi over 10. So meaning our z1 is going to be in this format, r e I theta. So in that case, this is going to be 2, because our r, we got it 2 here. So it will be 2e pi over 10i. That is the first value of z1. z2 is going to be when k is equals to be 5 plus 4 pi plus 1 to be 5 pi. So 5 pi over 10 is going to be 1 over 2 pi. Yeah, so our z2 is going to be 2 e is to pi over 2i. So that is the second set of the answer in that case. We're going to also, k is equals to 2. So if k is 2, it means our theta is going to be what? 8 plus pi, it will be 9 over 10 pi. 8, this is 2, k is 2 now. K is 2 in this case. We are going to say 4 pi times 2, that will give us 8, plus 1, it becomes what? It becomes 9 pi over 10. Therefore, Z3 is going to be 2e is to 9 over 10 pi. And that is going to be what? I. Up to that point, I believe we are together. So when you are finding complex numbers, you have to take note of that. to say k equals to 3, so this is going to be what? 12 plus pi, that's going to be 13. Yeah, that will be theta is going to be 13 over 10 pi, and z4 in that case, yeah, in that case z4 is going to be equals to what? Is going to be equal to 2 into 13 over 10 pi I, and then we have k equals to 4, theta is equals to 4. This is 16 plus 1, it will be 17, so it will be 17 over 10 pi, and therefore our z5 is going to be 217 over 10 pi I. So this becomes the roots of this question that we are having here. So let me just take you through another kind of question that you can be asked to solve, where r is greater than 0, those are conditions, and theta is greater than pi, negative pi, less than or equals to pi. So those are the conditions, and then you are supposed to work out this question. So the first thing that we are going to do, my guys, is that we're going to say that this is z cubed is equals to negative 4 minus 4 pi root 3 I. So basically this is what we are going to have in this case. And what are we going to do with this? So the first thing, whatever that we are having at this particular point, we are going to express this in argument form. So but before we do that, we need to draw an Argand diagram for the same, so which means that this is imaginary part and this is the real z. So this is negative. In the real axis we have negative 4, so negative 4 will be somewhere here, and we have negative z root 3, so which means that this will be negative 4 root 3 here, so which means our complex number will be down here. So we can be able to say our complex number will be down here. So in order to find the argument for this complex number, first we need to know what is this alpha angle at this point. What is this alpha angle there? Now to find this alpha angle, we are going to say this alpha angle, of course we are going to say angle alpha is going to be the tan inverse of opposite over adjacent. So that is going to be opposite. Opposite is basically this that we are having here, so it should be coinciding with negative 4 root 3. So negative 4 root 3 over negative 4 in that case. So if we work out that angle, we are going to get that this angle that we are having here is 1 over 3 pi. This is the angle that we are having at this point. But the argument that we were told to be giving in this question, our argument theta should be between pi and negative pi. So if we move this direction like this, by the time we are here, this angle will be more than pi, so we cannot be able to move that direction. So we should be forced to use this angle there. So our theta will be this angle, which is going to be negative, because we are measuring in the clockwise direction, is going to be pi minus 1 over 3 pi. That will be negative 2 over 3 pi. So which means this angle that we are going to use as the modulus for this particular question should be theta should be negative 2 over 3 pi, because we are measuring it in the clockwise direction and in order to reach at this particular point. So something else that we really need to understand here is to work out the modulus, and the modulus is going to be square root of this value that we have here. Yeah, is going to be square root of negative 4 squared plus negative 4 root 3. squared. And if we work out the modulus, in that case we are going to get square root of 64, and that's going to be 8. The modulus of this complex number that we are having here is 8, and the argument is negative 2 over 3 pi. So once we have done that, we can be able to say now our complex number that we were given here, where we are, is going to be what? Z cubed is equals to the argument modulus form. We shall have the modulus, and the modulus is going to be 8 cosine of negative 2 over 3 pi plus I sine negative 2 over 3 pi, like that. Yeah, so this is the modulus argument form of this particular question that we are provided here. So you need also to remember that this, we can be able to find the multiple angles of that. So Z cubed is equals to 8 into bracket cos, this it is going to be minus 2 over 3 pi plus 2 pi k plus I sine negative 2 over 3 pi plus 2 pi k, yeah, whereby our k is going to be equal to 0 plus or minus 1 plus or minus 2 plus or minus 3, and so on. So that is something that you really need to remember. But we can now say, once we have reached at that particular point, meaning that we anywhere we are going to have z, we are going to replace this part on this section here. So which means this z is going to be written as what? We're going to say this is going to be r cos theta plus I sine theta raised to power 3, because of this power 3 that we are having at this point, should be equals to, now we write this, and this is going to be 8 into bracket cos negative 2 over 3 pi plus 2 pi k plus I sine negative 2 over 3 pi plus 2 pi k, like that. So this is our equation. Now, since we're going to apply the Moivre's theorem, when you apply the Moivre's theorem, it means that if a number is raised to the power, if a complex number is raised to the power, it means the modulus is going to be affected by that power. So the modulus is going to be raised to that power, you are told, then according to the Moivre's theorem. So this equation is going to be r power 3 cos 3 theta plus I sine 3 theta is going to be equals to 8 cos negative 2 over 3 pi plus 2 pi k plus I sine negative 2 over 3 pi plus 2 pi k. And of course, we have already mentioned that this k is going to lie within this. K equals to 0, then you are going to find a set of values for z, because you are not going to find the exact value of k. You are going to have set value of z. So in this case, now we can equate this to this part, so that we r 3 power 3 equals to 8, which implies that our r is equals to 2. So that is the first beautiful answer we have that is going to enable us to work out these questions. The second part, we can say 3 theta is equals to any part of this, because this is the angle and this is the angle in this part. So we are going to say 3 theta is equals to negative 2 over 3 pi plus 2 pi k. Now, at that point of time, I really like it if I multiply all through by the fraction, so that I get rid of the fraction. So this becomes 9 theta is equal to minus 2 pi yeah, then plus 6 pi k, because I'm multiplying by 3 all through, and then my theta now from this equation is going to be theta is equals to negative 2 pi plus 6 pi k divided by 9. So this is the value of theta that we shall be using in order to find different roots, different values of z. Now we shall start by saying when k is equals to 0. When k is equals to 0, what will be the value of theta? Theta will be 0 times 6 pi will be 0, so theta will be negative 2 pi over 9. Therefore z1 is going to be equals to, we are supposed to write our answer in this format. So what does that mean? If we are writing that format, it means it will be r, and our r is 2, is going to be 2, e is 2, negative 2 pi over 9 I as the first answer in this particular case. The second answer, we are going to get it when k is equals to 1. So we are going to say when k is equals to 1, our theta is going to translate to what? This is going to be 6 pi times 1, it will be 6 pi, and that 6 pi that we are talking about is going to be we are going to say 6 pi minus 2 pi, that becomes 4 pi, and that becomes 4 pi over 9. Then our z2 is going to be what? Our z2 is going to be 2, e is 2, 4 over 9 pi I. That is the second solution for that. Next we are going to find when k is 2, and if we say when k is 2, there's something phenomenal that is going to happen. When k is 2, you are going to keep on having a look of the range of value of theta that you are told. Look at that. The pi should not exceed, theta should not exceed pi. So if we take k is equals to 2, you are going to have, this is going to be 12. You are going to have 12, because 6 pi times 2 will be 12 minus 2. Our theta is going to be 10 pi over 9, which is more than this. So if you want to go with this, you have to subtract 2 pi from this one. If you subtract 2 pi from this, let's check what answer will we get. It will be 10 pi over 9 minus 2 pi. The answer is going to be negative 8 over 9 pi. Negative 8 over 9 pi. Yeah, if you go for this case, you have to ensure you are reducing your answer to be within this by subtracting. But otherwise, sometimes you are not, you can avoid going that direction, because if 2 is going to give you a different an angle that is out of this, remember we said k should be 0 plus or minus 1 plus or minus 2 and so on. Now we use the 0, which is within the range. We have used 1, which is within the range. If you use 2, it will be more than that angle that we are told. So you need to resolve using negative 1. So that's, we can use k is equals to negative 1. Therefore theta is going to be what? Negative 1, and this is going to be negative 6 pi minus 2 pi. It will be negative 8 over 9 pi. The same answer we got previously when you subtracted 2 pi. So therefore Z3 in this case is going to be 2 e is to negative 8 over 9 pi I. So these are the roots of this particular question that we are given. And if you have gotten value from this particular video, consider subscribing, give this video a thumbs up. When I'm going to upload another tutorial, you'll be notified. See you in the next video.